Okay. So, before we go on to memory mapping or cache memory mapping, I'll first discuss average memory access time. Or the so-called AMAT. So, average memory access time is the time needed to request information. May it be a hit or may it be a miss. Please do take note that the formula for hit ratio that is number of hits all over attempts, while miss ratio, that is the number of miss all over attempts, or basically that is 1 minus hit ratio. Okay. So, just to reiterate, take note just to reiterate, the hit ratio or the hits, take note hits. Hits are when information needed by the CPU is located at the cache, while miss is when an information is not located at the cache. So therefore, our CPU or our computer needs to search for that information to our main memory or auxiliary memory. So please do take note that the hit time is less than that of the miss time. So, ibig sabihin, mas malaki po yung time pag yung instruction po na kailangan natin is hindi po siya located sa cache. Pag yung hit time po kasi natin, pag hit po kasi siya, ibig sabihin, nasa cache lang po siya, so mas mabilis po yung pag-process po ng information. Usually, miss time is considered as miss penalty. So, for us to go to average memory access time or AMAT, that is basically number of hits multiplied by the hit time plus the number of miss multiplied by the miss penalty or the miss time all over the number of attempts. Or basically, that is hit times hit time plus miss times miss time all over hit plus miss. Please do take note of that one. So example, imagine the CPU requests this information. So A, B, C, D, E. And we have the hit time as 5 seconds, and for the miss time as sabihin nating 15 seconds. So imagine this information. So let's assume that A, B, and C are hit, while D and E are miss. So the average memory access time or AMAT, that is equal to, ilan yung hit po natin? We have 3 hits, 3 times hit time, which is 5, plus miss, which is 2, times miss time or miss penalty, which is 15 all over 3 plus 2, or that is basically equal to 15 plus 30 all over 5. So that would be equivalent to 45 divided by 5, or that is actually 9 seconds. So given a certain requests, let's say A, B, C, D, and E, A, B, and C as hits, and D and E as miss, with hit time of 5 seconds and miss time of 15 seconds, then the average memory access time is 9 seconds. So that is memory access time. Okay. But what if, take note, what if the number of hits and number of misses are not given? Instead, the given is hit ratio and miss ratio. Okay. So, sample number 2. So, given is hit ratio, which is, let's say, ano ba? So, 3 over 5, and miss ratio as 2 over 5. So let's recall the formula of average memory access time, which is hit times hit time plus miss times miss time all over miss plus hits. Okay? So also, let's recall that the formula of hit ratio, that is number of hits all over attempts, while miss ratio is equal to the number of miss all over attempts. Okay? So based from this formula, take note that miss plus hits, that is actually the number of attempts. So basically, this one, H all over attempts times hit time. Then miss all over attempts times miss time. So you just need to add the two. Okay? Okay. So, in short, given the hit ratio and the miss ratio, the average memory access time or AMAT would be equal to, take note hit ratio times hit time plus miss ratio times miss time. So, AMAT or average memory access time would be equal to hit ratio times hit time plus miss ratio times miss time. So given this one, we have the hit ratio and the miss ratio. So we have the hit time as 5 seconds, and then we also have the miss time or the miss penalty as 15 seconds. This is still, take note this is still based from the previous example. But instead of the number of hits given, it should be hit ratio and miss ratio. So fraction lang yung ginawa ko para mas mabilis. But this could be let's say for example 0.5 or so on. Or, wait lang, i-compute natin kung ano yung 3.3 over 5. Calculator. So that is 3 divided by 5. That is 0.6. So the heat ratio would be equal to 0.6, while the miss ratio, that is 0.4. Okay. So imagine if this is the given. So 0.6 and 0.4. So that would actually, so heat ratio is 0.6 times heat time, which is 5 seconds, plus miss ratio, which is 0.4 times miss time, which is 15 seconds. So that would be 0.6 times 5 plus 3. Okay, so this would be equal to 3 plus, okay? So 0.4 times 15, that is equal to 6. So that would be equal to 6. So still we get 9 seconds. And that's all for average memory access time. Now, let's proceed to memory mapping. Okay. So, let's now proceed to cache mapping. So, there are 3 types of cache mapping. That is number 1, direct, then full associative or fully associative, and we have set associative mapping. So set associative mapping. So these 3 are the 4 techniques in memory or cache mapping. So let's start first with the definition of direct mapping. So direct mapping is when, wait lang. Nagaganyan. Okay. So direct mapping, so let me define direct mapping. So direct mapping is when a memory block is assigned to a certain cache lines. Certain cache line. So meaning, a certain or a single memory block is assigned to a certain cache line. Ang ibig sabihin po niyan, kumbaga is meron siyang fixed assignment. Fixed assignment. So yung memory block po natin, may designated na na cache line lang po na pwede niyang paglagyan. So let's say for example, this one. So we have a memory And then we have a cache. And so imagine this one. This memory block is designated only to a fixed position in our cache line. So kumbaga, dito lang siya malalagay. And then this one is dito lang siya malalagay for the second one. Parang ganun lang po siya. For you to better understand this one, I created a separate video for direct mapping, poly associative, and set associative natin. So next. Next, we have number 2, full associative mapping. Okay, next is fully associative mapping. So, ang fully associative mapping naman po, an incoming block or an incoming memory block is assigned to any available cache line. So let's say, for example, this one, we have a memory, then we have a cache. So if we are to store this one, so we store it to the first available cache line. Then if we are to install a second one, we are to install it to the next available cache line. Then if there is an incoming, then ilalagay nyo po siya sa any available cache line. Unlike kanina po, dun sa direct mapping po natin, there is a designated, let's say for example, an incoming block or memory block, there is a designated cache line kung saan mo dapat siya ilagay. That is the difference between full associative and direct mapping. Okay, next. Number 3. So we have set associative mapping. So when we say set associative mapping, this is basically a combination of direct mapping and full associative mapping. So combination of direct mapping and associative mapping. Okay? So ang ibig sabihin po niyan, cache lines are subdivided into different sets po natin. So kumbaga, yung mga cache line po natin, mag-grupo-grupo po sila. There will be a group of cache lines. And then, so parang ganito. Ayan. So we have our memory and we have our cache line. So imagine this is our cache lines. And for the first two, this will be, imagine block 1. And for the second one, that would be block 2. Anong ibig sabihin po nun? So imagine this one. There will be an assigned block. So meron po siyang dapat naka-assign na block na pupuntahan. So kumbaga, pupunta siya sa block 1. So ilalagay po natin yan. Pero dalawa po yung spaces yan. Now, for this one, so let's say, pupunta po siya sa block 2. And then again, ito, pupunta sa block 1. Now, of course, may empty pa doon. So, ilalagay nyo po siya doon. Parang kumbaga combination lang ng full associative and direct mapping. So, that's all for the introduction of cache mapping. So, for the succeeding videos, it would be the full explanation of the different mapping. And that's all. Thank you.